We've got, in a minute, I'm going to bring on Nishi and Maksym from Salesforce, who are going to talk about buzzword in buzzword about buzzwords. In their defense, I came up with the title, so I can't say anything. But they're going to talk about how they use Honeycomb at Salesforce as part of their DX team, and they've got some migration stories, which is amazing. It's been really good working with them to do that. After that, we're going to have Jody from Stack Overflow going to come up and talk about documentation, and then downstairs we're going to have Will from Akamai, who's going to come and talk about the SRE relationship. One of the themes that you're probably noticing over the day is trust. How do we trust agents? How do we trust the outputs of humans when agents are involved? So keep that in your minds when you're looking at these talks. So let's bring them on stage.
All right. We're not going to sit, because I love to stand and entertain my audience, right? How are we doing today? Right after lunch, right? Is everybody awake? Yes? Okay, 1, 2, 3. All right, we're ready. Okay, who works in developer productivity? Anybody in the audience? Okay, I see a few hands. Okay, you'll probably make more sense of what I'm saying. Who knows about agentic software engineering? Everybody? Okay, a few more. And who has Honeycomb at their shop, at their enterprise? All right, few. Okay, so I think my presentation is going to maybe share some light on how we do this, and maybe give you some insights on what needs to happen at your places to get on, and so on and so forth. All right, so yeah, I am very thrilled to be able to share my thoughts on what we do at Salesforce with respect to the observability AI, aka Honeycomb Intelligence, and how that is fueling agentic software engineering in my team specifically. What I do here at Salesforce, it's been a fun, transformative, challenging 14 years. And I manage teams who deliver platforms, products, and services for internal developer productivity at scale. We have more than 8,000 developers using our platform globally. And I cannot be more excited for this challenging time we are on, where we are turning the roads from SDLC to ADLC. We are challenged by the developer every single day, and we cannot wait to deliver to those challenges and transformations. Max is a senior software engineer on one of my teams, and I'll let him introduce himself and what this shift means for him.
Hi all. I'm happy to be here today and really happy to see all of you faces. So let me share a story with you. I joined Salesforce roughly 1 year ago, and I'm most recent probably addition to the team. So when I joined the team, the immediate thing what I observed, it's what we have telemetry. We have spans, traces, but it was dry. It was, to be honest, meaningless. But we did not have observability. Observability, Nishi will present what actually it means, observability. So with that, I personally started challenging myself, pushing myself further out of the box, what we can do better. Because the reason behind that, it's when your management asks your question, simple question, why this behavior happening to your customer, how you can explain why this or that is happening, and simply you cannot give this answer, that's when you start looking for answers. And usually what we do as software engineers, we quickly look at solution, yeah? But that's not the right approach. The right approach was at that point of time to start looking what we don't have, what we are blind. So what we did, we start cataloging. We did inventory of our spans, what we have. The next basically column was what business value it represents. Sounds obvious, yeah, Captain Obvious, welcome to the room. But actually, specifically that was the beginning of our journey. And that journey started transforming everything in our team. Because right with that, we start delivering feature by feature, small improvement was like small improvement. Basically, traditional software engineering, nothing like specific, you know, like iteration by iteration. And with that, our journey keep going. And of course, we hit the obstacles. Who don't hit it? If you ever work on proprietary software or IntelliJ, anyone worked on IntelliJ plugin SDK? So you know a bunch of obstacles, like, but if you go one level deeper, you open like fundamentally new, you know, like new area, new landscape. And one of these landscape, basically Java itself, you know, you open something new for you and start pushing yourself again out of the box. And that Nishi will share with you a story, of course, how we brought exception monitoring and everything. And to conclude, basically, what happened with me personally as a like software engineer and the rest of our team, we started looking simply to our data as dry data points or simply dashboards. We start obsessing like what value behind all of this stuff and how we can make all of this stuff actionable. And that, I suppose, allowed me personally to become a better engineer. And with that, I want to transition the rest of the conversation to Nishi and allow keep going. Thanks.
All right. Thank you so much, Max. So awesome. We are going to split this presentation in two parts. First, of course, we're going to talk about my engineering team's journey onto Honeycomb. And like Max said, you know, everything was a dry, barren field before, and then we made it rich. So we're going to be very honest about that everything was a learning for us, and we benefited from there. And then I'm going to, in the second part, share success stories, and Max was involved in those success stories, where real-life events happened with our customers and how we used Honeycomb and Honeycomb AI to kind of get to the bottom of it, be able to triage it, where system diagnostics went from being reactive to proactive, right? So the foundation for us in terms of observability was really moving to open telemetry, right? Instrumentation without proprietary ties. This was a given. And about more than 2 years ago, where we were in this crunch period of having to build and deploy an extremely important service at scale. So the biggest question in the room for my ICs, my POs, my PM, my architect, and me were, what are we going to do if stuff shoots production? Like, what are we going to do? Because we don't have time. We're going live. We're going live right away. And yeah, it was just that. And for us, Honeycomb was the answer. We needed to go, like I said, from diagnosing a system to being able to proactively know what's happening with the system, to be confidently operating the service. And it's a global service. We knew that. So EMEA, APAC, EMEA, LATAM, everybody, all the developers around the world were using our service, right? So that also meant our developers were transitioning from being software engineers to SRE, to be on call, to be on support. And that was the biggest transition for us, for them to understand MTTR, MTTA, incident response, PagerDuty integration, and Honeycomb was the answer for all, because the integration was so tight. So some of that came pretty easy, but then that's when, you know, the real story unfolds. I just want to take a step back to say that observability and engineering, not too long ago, were considered as two different things, right? I just alluded to our teams having to transition from software engineers to SRE, but I do notice that there are still considered as two separate worlds. You have disciplines of software engineers, you have discipline of site reliability engineers, and I don't think that exists anymore. Today, that world has collided, right? My teams sit at the intersection of platform engineering and, you know, developer productivity. We are building and operating services for the engineer who is also observing everything. So the context is switching for us, how we think of observability. We're being observed as we are observing our systems. So with that, when AI became much more predominant, and for us it was, I believe, you know, a year ago when it became really predominant, and Honeycomb had its MCP integration available to us in most of our stack, this was a value change for us. This was a game changer for us where we found out that reducing friction between the coding loop and the feedback loop was really how we would get on the stack of AI tools. The number one barrier for us to embrace the different AI tools that were available in the market was bandwidth. And Honeycomb made it super easy for us. And you'll probably see it how when I share the success stories. One thing I want to note is, as we were on this journey, it was not just engineers like Max that were absorbing this. It was also the TPMs. It was also the engineering managers. It was also the product owners. It was also the product managers. Like every single discipline in my organizations and my sister organizations were looking at this. Why? Because Honeycomb made it so easy. It's natural language processing. It's a prompt. If you know how to give a prompt, you know how to use Honeycomb. You don't need to necessarily know data sets, right? You can process it. So we started seeing all disciplines within our SDLC organization at that point, and this is 2.5 years ago, starting to use Honeycomb for communication, for surveys, for technical enablements, for project milestones, for everything. Data was rich and it was flowing through all kinds of activities that were happening as part of like day-to-day. Well, it's time to now shift to the success stories. So the first story that I'm going to say, and it's really that tagline that I'm putting there, from blind to brilliant. That was really where we saw us changing ourselves on how we are using Honeycomb, and it's been no return from there. So a little bit of context to that success story is not too long ago, we moved one of our very large Java monolith code bases from a very custom packaging build management framework to Bazel. Everybody knows Bazel? Yes, Google's Bazel, yes. All right, little did we know that the 8,000 plus developers that were working on this very giant Java code base had started to see a lot of inconsistencies with their Bazel sync times, Bazel build times. Sorry, I'm going to go a little bit into sort of the software development, activities, so bear with me, but I'll get to the point. So they started to see this, and we did not know what is happening. Why? Because we were focused on the bare bone of Honeycombs. We had Honeycomb telemetry set up for the IDEs where they were working. We were looking at indexing, and we were looking at scanning code. We did not know what was happening, and there was 1 out of 4 developers that was basically being affected. Fast forward, I just wanted to show this slide. This is literally from 3 months ago that we are able to reduce the impact of what happened with that incident in December 2025 to less than 1/4 of people now that are seeing some issues. And this was only possible with what we're going to talk about in the next upcoming slides. All right, so essentially, as I told you, there was a developer crisis. More than 2,500 developers per month were telling us that they were frustrated. There was something going on, and they did not know, and it was affecting how they were delivering code, right? And this is probably a P1 for me, because I necessarily don't have a workaround for them. I need to, diagnose and triage a case at a time. And that's not how I operate, right? So we immediately knew that we needed to observe the system, and what telemetry we had set up was not giving us the observability. So thousands of developers were telling us there was something wrong, and we were here guessing what the problem would be. And we had to shift that, right? So that's why I call it the invisible problem. We had spans coming from Honeycomb, but they were dumb. They did not tell us what was going on. This is where we had to really do something. So Honeycomb was telling us, guys, you need to do more here, which was a great place for us to be, right? And so really, the co-pilot along with us along the journey, we had to make that change, right? So a little bit into what was going on under, this is what we were guessing, that there is probably something in the framework that is causing this issue. And yeah, we were looking at the code, but again, this is the time we were trying to build the telemetry to see what needs to happen, right? These were the signals we are getting, that there are some violations happening that is causing performance degradation. There is a quality issue here, and developers are telling us. And so this is, I'm just giving you details of what was happening on the ground, and all the signals were telling us that we need to know more, we need to understand more. That's when we introduced exception monitoring, right? And as you can see, the dumb span has now transitioned into a structured span attribute, sets of attributes that are revealing to us the project views of the various Bazel developers that possibly have issues, the violation flags that have possibly causing the performance degradation, right? So it's a turning point where telemetry is going to be our first-class feature when we start to change the development of this particular class and instrument it to be able to understand these spans better. Right? So first milestone is telemetry is not an afterthought. It is part of your feature development. All right? This is also, and the title is, I wanted to show this slide because I also want to point out that, yeah, you can do telemetry, but if you do not do it the right way, you're going to end up with data that is absolutely wrong, right? So this kind of telemetry was telling us that duration-only spans are not sufficient. You need to add more rich attributes and quality checks on the span. And this was the second milestone for us, that every span that we get needs to be structured, intentional, and meaningful. That data is the data you should be able to count on, and this was the second point for us in that journey. So what we did was we took these pointers, we did some more instrumentation, and then we actually started to see why the possible regression could be. We actually saw the various project views that the Bazel developers were in. What were the different combinations for those? The spans were telling us that some developers were using extraneous large packages and directories in their project views that were causing performance degradation. So some of these things started to come to us, and first time we were seeing the different buckets and reasons of the configuration drift happening across the fleet. And even, like I told you, there were compliance checks that were raising violations. So this was what Honeycomb put to us. And it told us, remember that trigger in the framework that supposedly had the problem? Yes, that was the problem. When combined with problematic directories, it was actually causing performance degradation. So with that, we were like, okay, now we have data with that rich information telling us what's happening. We took that, instrumented the code further, and we were able to look at all of the project view content, about 4,000 events. We were able to look at the memory pressure happening on the events. We were able to look at all of the compliance checks with the violation flags combined with the problematic directories, and what was happening per user, per configuration in the Bazel sinks. All of that was possible because we were on the Honeycomb journey to improve our telemetry and dig deeper into richer spans. And that is the end of the first story for us with Honeycomb, right? The second story, this one is near and dear to me because this is where the flow of work never leaves your AI, whatever AI tool you're in, right? So essentially, the story is we have multiple developers every single day running hot swap. Anybody know what hot swap is? No? Okay, all right. So when you have a bunch of UI pages and you have basically Java code, if you want to make changes to your UI pages, you could make the JSP changes and you hot reload them on top of your running core Java or your Java server. And that's how you test whether your pages are displaying correctly, so on and so forth, right? And so depending on the number of classes that are getting reloaded when your UI pages are getting displayed, you might see a performance issue or not. And yes, our developers were telling us that they are seeing performance issues during hot swap. And hot swap was one of probably a very popular operation that developers would run every single day. So we had to fix it. So what did we do? We didn't just take the code and start to fix it. We did what we had learned to do all this while. We basically wrote a new span, Bazel hot swap, in the tracing object in our custom plugins that was monitoring all of this. And we added rich attributes on it. As you can see, the span name, change classes, change jars, all that stuff. And essentially at that point, and as you can notice, this is in Claude, right? And Honeycomb MCP is available to Claude at that point. So essentially what's happening is we had Claude tell us what is going to be happening with that integration we just wrote. So we told Claude, hey, why don't you create a dashboard in Honeycomb for us with the span we just wrote, with some of the metrics around the build that are related to it, and give us some stats that you think are important. Mind you, at this point, we have just given the bare bone. We have just told the name of the data set. We have not said anything about the query, about the columns, nothing at all. And what does Claude do with one natural language request? It basically creates the dashboard, connects to Honeycomb MCP. You can see the connection right there. Creates the dashboard, gives us the 7 panels, and tells us exactly what we're looking for. Here you are, within a session, no context switching, no other browser navigation, no manual query construction. All you need is a natural language, single prompt, and maybe some information on what you want to get at, and that's it, right? And you have the query and the board ready for you. So essentially, what would have taken us hours, maybe, to build, that board was ready, possibly even in seconds. Like, I think it was very quick. It was very quick, yeah. So here you are. The point that I want to bring up is you saw the prompt I gave Claude. I didn't tell anything but the span and the data set. And it was able to infer, hey, here are the metrics that you would want to know. Here is the hot swap success rate. Here is the trend line. Here is the duration, right? It came up with that and told me conversationally in Claude via MCP that this is what you need to track, right? And it also told me a few other things, right? That if you're looking at the build stats overall and how hot swap is a part of all of that, here are some more metrics that you want to look at. So right now, an engineer as Max, and this happened to the team where Max is a part of, does not have to leave Claude, does not have to go to Honeycomb. He has to integrate the MCP within Claude, and we are single prompt be able to have feedback about the code and what needs to happen right away. That's the power that I'm talking about. All right, and as you know, if you've used Honeycomb before, drilling into any single trace from Honeycomb is really what it is, right? When you see anomalies or what's happening with a single trace, right? You can drill into it, look at the rich attributes, and be able to tell, oh my gosh, like, okay, so for us, if you think of it, when we get customer cases that there's a problem, we literally look at the trace ID in Honeycomb and be able to see, okay, what's going on with this customer? That is the power I'm talking about. And this is, at this point, this sounds very reactive, but we have these boards available to us now. So we're not waiting for the customer to log a case. We know what's happening in the system. Those alerts and signals are already available to us. And that's the power of Honeycomb within your Claude or not Claude or Cursor, whatever you use. But we've already seen the intelligence layer come through for us. All right. Do you remember that first success story I showed you? I didn't think I showed you anything about an AI layer on top of it at that point. That happened a little bit when we were not integrated very closely with the Honeycomb MCP. And so what we decided to do is let's bring those classes that we instrumented at that point with where there was the Bazel issues with the builds and things. Let's bring those back into Honeycomb now with the intelligence layer and ask Claude with the Honeycomb MCP integration that, hey, check the logic in the 2 files that we instrumented. Tell us what data is it producing. And voila, Claude was able to understand the code, read the span attributes, and tell Honeycomb Canvas to analyze what is going on, right? So this is where your code is talking to your live telemetry. That's the power that the agentic software developer needs to have today. So Canvas comes back with these findings. As you can see, design decisions, and it tells us what's happening. What's happening is the amazing part, it tells us that those compliance checks that were failing for you, those violations, they were actually because your spans were firing in some weird preconditions. And we did not know about that. That was a finding that was something that Canvas told us by evaluating all the span attributes and the data along with Claude, right? So now, we are ready for what that looks like. Yes, it's a busy board, but look at it. All of the data in one place in the canvas, where now we're not just seeing what the patterns were, what should have happened, but we're also seeing recommendations from Honeycomb that these are the panels you want to add to the existing board to stay on top of the problem. It's telling us that if you want to look at the top offenders to stay on top of it, if you want to look at sort of like a fleet-wide, what would happen if this changed, here is what you need to do. For me, as an engineering lead or as a manager, I want to send this right to my executives, right? When they ask me, hey, what's happening with your system? Why are there 2,500 developers telling me there's a problem? I have the synopsis ready for me, where I tell them, we'll figure out the problem, we even have the next steps, and we're going to stay on top of this to solve further, right? They love that answer, that you're on top of your game, right? And Honeycomb enables us to do that. So, with that, I want to leave you with a few lasting slides. One is basically we're all in this AI-assisted development, or even like you say we're developing with AI. Like whatever the stage you are in, we're already there, right? And so for me, coding is not a problem. You can code with agents. That's not a problem. I think the biggest thing that I'm solving for is how can I shorten the feedback loop? Can I think of the feedback loop when I'm developing? Can telemetry and instrumentation be a first-class feature as part of my product development versus an afterthought? Can that be done in the flow of work? So for me, collapsing that feedback loop is now becoming very important. Write it, ship it, verify it in one flow, and if you can, in production. Right? That's what Honeycomb says, I test in prod, right? And we believe in that. We actually believe in that. And I'm happy actually to say that a lot of the software engineers on my team are now in this new frontier, right? They're not looking at writing code every single day. They're looking at designing the code with the feedback loop in place, right? So they're courageous enough to say, oh, we have Honeycomb AI. We need to make sure we have our eyes on the problem, we have the clarity, give that problem with the MCP, where we're able to understand what will happen if this code ships from A stage to B stage. Should we do it now, or do we need to add more gates? All of that planning and designing is happening at the left of that ADLC versus waiting for the feedback to come in. Right? And this is done so seamlessly. That's why frictionless integration is becoming probably the most important thing for me. It's like, if I have the MCP and the code, so the code awareness orchestration in Claude with the data native integration that Honeycomb Canvas brings in, if those two things are talking to each other, I think agentic software engineering is going to be flying. It's going to be flying with success versus slop, right? We've all heard of that. Right? Nobody's new to that. All right, so a couple of key takeaways that I wanted to share with you is, first thing, at Salesforce for my teams, oops, I should not touch that. But Salesforce for my teams, we have not been very, I would say, sure of what observability means from day one. It was a journey for us. It was an evolution for us. We, like Max said, we were flying blind before. We had telemetry, but we didn't know what it was telling us. So we had to get on the journey of making it production quality. We had to leverage Honeycomb. We had to make sure Canvas has given us the insights and not the noise. And that was an evolution for us, as you see from my couple of success stories. And that's where my teams are today. They are basically writing code with Honeycomb in picture, and they are able to ship with confidence because they are observing continuously, and they are instrumenting early in the cycle. Like I said, instrumentation is your feature. It's not something you bolt on later, right? So as an ending remark, what I want to leave you with is what I'm watching. What I'm watching is the line between, hey, I'm a software developer writing code, and I need to understand what's happening in production. That line is blurring very rapidly. And AI-assisted development and AI-augmented observability is enabling sort of that convergence, in my opinion. So if you are in software engineering and you're not thinking about this, I am going to tell you that there's probably a gap, and you might want to kind of think about that a little bit more. At Salesforce, we are locking ourselves in the strategy that we want to be at that convergence. And I believe that we are building towards that. I'm building my teams for it, and I do believe that Honeycomb is also building towards that convergence future. Thank you so much.
Thank you.